Alright, now that we have seen the algorithm using binary searching for finding the effective insert position of a particular target value inside a sorted array of values that we have been given, such that even after inserting that specific value the array will still remain sorted, right? Now that we have seen the binary searching specific algorithm, let's quickly write the C++ implementation of it as well. So here I have defined the class, and I have written the code for calling the specific function and everything. Let's just quickly dive into the implementation. So here let me just define couple of helper variables. Since we are going to use binary searching, let's get started with start and end. Let's also implement the end. End is nothing but whatever the size of the array that we have got minus 1. Along with that, we will also define one variable middle, and we will be initializing it with minus 1. Now what we will do, simply we will be running a loop as long as start is less than or equal to end. We will simply calculate the middle. Middle is nothing but start plus end divided by 2. Once we get the middle, whatever the value we have at this middle index could be this target value. So we can simply insert this target value at this middle index itself. So for that, what we will do, if at all the value we have at this middle is equal to the target that we have got, in this case let's simply return middle itself. If this is not the case, obviously two other scenarios are: whatever the value we have at the middle is greater than the target value, whatever the value we have at the middle is smaller than the target value. Now let's just write the logic for both those scenarios. If at all the value we have at the middle is greater than the target that we have been given, in that case what we need to do, we need to find the appropriate insert position somewhere on the left of the middle. That's why to continue the search on the left part of the array, what we will do, we will update end with middle minus 1. If this is not the case, obviously the other scenario is whatever the value we have at the middle is smaller than target. In that case, what we need to do, we need to search for the appropriate insert position somewhere on the right part of the array, right? For searching that on the right part of the array, let's update start with middle plus 1. Now once we complete executing this while loop completely, right, whatever the value we have inside the start variable will basically represent the index at which this target can be inserted. So here we will simply return the start itself. That is the position at which we can insert the target value, such that whatever the array of values that we have got also remain sorted. Okay, that's it. That is the effective way of writing the solution for this problem using binary searching technique. Now anyway, we have written this caller function and everything, right? Let's just call this function and validate. Let me just cross check if I have closed everything perfectly. Yes, everything is perfect. Now here the array of values that I'm passing is 1 2 3 4 5 6, and the value that I want to insert is 5, and 5 is already available, right? And we can still insert 5 at index 0 1 2 3 4. So the value of 5 can be inserted at index 4. So if I run this code right now, the output should be 4. So see, the output that we have got is 4. Let's just say here we don't have 4 and 5 inside the array that we have passed. We just have 1 2 3 and 6. We need to insert this 5 before this 6, right? So we need to insert 5 at 0 1 2 3. At index 3 we need to insert 5. So if I run this now, the output is 3, which is where this 5 can go, such that the array still remains sorted. Okay, now once again let's just say the value that I want to insert is minus 5. Minus 5 should be inserted at index 0, because 1 is the smallest value so far. Minus 5 will be the smallest value after inserting, right? So it should go at index 0. So if we run this now, see, the output is 0. Okay, you can test any other case. Let's just say we are passing an empty array. In this case, since the array is empty, obviously whatever the value that we are trying to insert will be going at index 0 itself. So now see, the output in this case also is 0. Okay, so that is how we write the solution for this specific problem using binary searching algorithm effectively. Okay, so that's it for this one. I'll see you in the next problem.